Our mission this week is to give you the ultimate shortcut to understanding the relentless pace of innovation coming out of AWS.
It's a lot.
It is a lot. We're tackling 69 major announcements, all dropped between December 1st and the 8th. This is an information fire hose.
For sure.
And if you're trying to stay fluent for your next technical discussion, this deep dive is pretty much essential. We're not here to read marketing copy. We're here to extract the architectural shifts and, the practical takeaways.
It was an overwhelming week, I'll admit. But when you zoom out, the massive volume kind of collapses into two strategic movements.
Okay.
First, there is just an aggressive foundational build-out for generative AI. We're talking more models, better efficiency, massive accelerators.
And the second?
The second is maybe a bit more subtle. It's the move towards operational autonomy. The cloud is evolving from just being a resource provider to, a self-managing system driven by AI agents.
Got it.
So we've filtered all 69 updates into 4 categories: core AI and model velocity, high-performance compute, data scale and cost optimization, and finally, agentic operations and security.
All right, let's dive in. Let's start with that sheer volume of new foundational models flowing into Bedrock. What were the most significant third-party additions?
The expansion was the largest to date. The headliner is definitely Mistral Large 3.
Right.
A really formidable model. We're talking 41 billion active parameters, a staggering 675 billion total parameters,
Wow.
and a massive 256K context window. This makes it instantly available for these really complex enterprise workflows.
Things like processing huge documents or long-running conversations.
Exactly. And you also get the full family, the Mistral 14B, 8B, and 3B models. So you have an option for the edge or for massive scale.
And it wasn't just Mistral.
No, we also saw Google's Gemma 3, NVIDIA's Nematron Nano 2, Moonshot AI's Kimi K2, a total of 18 fully managed open-weight models.
That diversity is crucial. But AWS is also investing heavily in its own Nova family. Now we have Nova 2, and it seems like they're segmenting its capabilities pretty dramatically.
They are.
So does this level of specialization, Light, Pro, Sonic, Omni, does that actually simplify life for the developer, or does it just push the complexity of model selection onto us?
That's the critical question, isn't it? I'd argue it's a simplification through specialization. AWS is moving away from the single monolithic model idea.
And providing a segmented AI stack instead.
Exactly. Nova 2 Lite is your cost-effective reasoning engine for daily tasks. The Nova 2 Pro is built for the highly complex multi-step stuff.
And that's the one with the 1 million token context window.
That's the one. And it introduces features like step-by-step reasoning. What's smart is the developer control. You can select thinking intensity, low, medium, or high to manage that trade-off between speed, intelligence, and cost.
Okay, and Nova 2, Sonic, and Omni fill in the other specialized roles.
Precisely. Sonic is purely for real-time conversational AI. The key upgrades are these highly realistic polyglot voices.
Meaning the same voice can switch languages natively.
Natively, yeah. And it has cross-modal interaction, so you can switch between voice and text in the same session. And then you have Nova 2 Omni, which is in preview.
Right, the ultimate consolidator.
That's the goal.
Omni takes everything, text, image, video, speech inputs, and then generates text and image outputs. It feels like a direct answer to competitors who make you stitch together several API calls.
That is exactly the play. It's multimodal reasoning with that huge 1 million token context window, eliminating the need for complex orchestration layers. If you can stay in the ecosystem, you slash your operational overhead.
Okay, let's connect the models to the tooling. Bedrock now supports automated reinforcement fine-tuning. For listeners who aren't deep in ML workflows, what exactly is RFT and why is automating it such a big deal?
So RFT is essentially letting the model learn through trial and error. It's based on human or automated feedback, rewarding it for good responses, penalizing it for bad ones. It's the next level beyond static tuning.
And automating that.
Automating this advanced workflow means developers without specialized ML teams can now get accuracy gains of up to 66% on average. And that, combined with Nova Forge going GA, means you can build your own frontier models from early Nova checkpoints.
Okay, and to support the training of those huge models where failures are common and really expensive, SageMaker Hyperpod got 2 game-changing features.
Right. This addresses that core fear of distributed ML watching millions in compute time just vanish because one instance fails.
So how does Hyperpod redefine failure?
Well, first, there's checkpointless training. It maintains forward momentum despite component failures. It's an abstraction that reduces recovery time from, hours of rollback down to just minutes.
So it keeps those expensive accelerators actually working.
Exactly. And second is elastic training, which automatically scales training jobs based on resource availability. It can absorb idle accelerators into your job or shrink it when needed, all without halting the training.
Which brings us nicely to the raw silicon underneath all this. Let's shift from software to the latest processors, starting with AWS's own, Graviton 5.
Right. The Graviton family is relentlessly focused on efficiency and cost performance. The Graviton 5-powered M9G instances are in preview, and they're promising up to 25% better compute performance than the Graviton 4-based MAG.
More efficiency, pure and simple.
Pretty much, along with better networking and EBS bandwidth.
But at the same time, AWS is leveraging peak performance from partners, specifically AMD's 5th-gen EPYC. We saw a new speed milestone, 5 GHz max CPU frequency. Who is that actually for? Is this AWS trying to win back specific HPC workloads?
That's exactly it. When you see M8s and instances hitting 5 gigahertz, that is not for your average web server. That frequency is crucial for software license per core or for single-threaded workloads.
Like electronic design automation, or EDA.
EDA, some financial modeling, game development, yeah. These M80 instances deliver double the compute performance over the M5's N generation, mainly because of that high clock speed.
And that ultra-high frequency is also in the specialized memory instances.
It is. The Arcades instances, which are key for EDA, have that 5 gigahertz frequency, a huge 32-to-1 memory to vCPU ratio, and up to 3,072 gigs of memory.
And for standard compute.
For standard compute, we got the C8A instances offering up to 30% higher performance than the C7A. The message is clear. Whether you need efficient ARM or absolute peak speed, they have an instance for you.
Speaking of peak performance, let's talk accelerators. AWS's custom AI chip, Trainium 3, is now generally available in the Tren 3 Ultra servers.
This is a major internal leap. Trainium 3 is their 3-nanometer chip, offering 2.52 PFLOPs of FP8 compute per chip and 144 gigs of HBM3E memory.
Which translates to what kind of performance jump?
The Tren 3 Ultra server delivers up to 4.4 times higher performance over the Tren 2 generation. If you look at this combined with the new Nova models, you see a vertically integrated strategy.
Optimizing custom software to run on custom hardware.
Exactly. And at the same time, the P6e GB300 Ultra servers, running NVIDIA's GB300, also went GA, ensuring there's choice for people deep in the NVIDIA ecosystem.
Okay, rounding out compute, we saw an update for networking and one for Apple developers.
For networking, specifically high-throughput workloads like security appliances, the EC2 C80 instances are in preview. They use Intel Xeon processors and the new Nitro V6 card.
Delivering what kind of packet performance?
Up to 2.5 times higher data plane packet performance per vCPU versus the C6N. It's pure throughput optimization. And yes, Apple developers got the M4 Max Mac instances, a significant power boost with that new M4 Max Mac Studio hardware.
Okay, let's move to our third pillar, data storage and cost optimization.
Right. This is all about how we scale data storage and improve database efficiency, which is often tied directly to those expensive commercial software licenses.
Starting with S3, we saw a simple but massive scaling
A
increase.
huge one.
The maximum object size jumped tenfold, from 5 terabytes up to 50 terabytes. That's a huge simplification for handling single large objects like seismic data or AI training archives.
And all S3 features and storage classes just instantly support this. It's a convenience update for sure. But the real game changer in S3 for AI is S3 vectors moving to general availability.
Okay, explain that transition. Why is native vector support so different from running a separate, dedicated vector database?
Well, S3 vectors provides native vector indexing right inside your object storage. The scale is immense, up to 2 billion vectors per index. But the benefit isn't just scale, it's operational cost.
Because you're not moving data around.
Exactly. You could see up to a 90% cost reduction for upload, store, and query because you eliminate that data movement and management overhead. Plus, it maintains near real-time latency, which is essential for workflows.
It makes retrieval augmented generation way simpler and more accessible.
Yeah, of course.
Now, shifting to databases, RDS introduced optimized CPU for M7i and R7i instances. It reduces costs by disabling SMT, or hyperthreading. Why would disabling a performance feature lead to cost reduction?
This is a direct attack on commercial software licensing. Most enterprise databases, like SQL Server, are licensed based on vCPU count. SMT gives you 2 virtual CPUs for every 1 physical core.
So you pay for 4 cores, but you're billed for 8 vCPUs.
Correct. Optimized CPU lets you disable SMT, cutting the vCPU count and your license cost by half, while keeping the physical core performance. If your workload isn't perfectly threaded, you can save up to 55% with almost no performance hit.
That's a phenomenal detail. They also increase storage capacity pretty dramatically.
Yes, RDS for Oracle and SQL Server now support up to 256 terabytes of storage, and crucially, you can attach up to 3 additional storage volumes.
Which lets you mix and match for cost and performance.
Right, you can mix high-performance IO2 volumes with more cost-effective GP3 volumes. It gives you granularity that just wasn't there before.
And that cost focus was generalized across the entire fleet with database savings plans.
This is a new pricing model with up to 35% savings, and the flexibility is the key. The plans automatically apply across multiple database engines, Aurora, RDS, DynamoDB, you name it, and they're independent of region or instance size.
Which is huge for modernization projects.
It is. If you commit to a plan and then migrate from, say, legacy Oracle to open source Aurora, your savings commitment still applies.
And finally, we saw CloudWatch and OpenSearch strengthening their observability data management.
CloudWatch now provides unified management and analytics across operational, security, and compliance data, and they simplified collecting CloudTrail events.
And on the search side,
OpenSearch Service added GPU-accelerated and auto-optimized vector indexes. This is massive for anyone building their own vector platforms because you can build billion-scale vector databases in under an hour, eliminating what used to take weeks of manual tuning.
okay, we've saved the most transformative category for last agentic systems.
This is where the cloud platform really starts running itself.
And we saw 2 major frontier agents aimed at critical operational tasks, DevOps and security.
Yeah, these are proactive AI agents.
Mm.
The AWS DevOps agent is built for operational excellence. It continuously monitors and proactively prevents and resolves incidents. It triages autonomously and gives you actionable recommendations.
So if you've been paged at 3 a.m. for a failing deployment.
This agent is the promised land.
And the AWS security agent operates in a similar way for security.
Correct. It focuses on proactive app security, running automated security reviews, and context-aware pen testing throughout the entire development lifecycle.
It turns security into an always-on process, not a periodic audit.
Exactly. And GuardDuty also enhanced its detection for multi-stage attacks on EC2 and ECS. Instead of isolated alerts, it now gives you correlated findings with high-level context, like attack sequence.ec2 compromise instance group.
And the most robust deployment of these agents is in modernization, with AWS Transform reaching GA.
AWS Transform Customs, GA, yeah. It automates organization-wide modernization, like Python or Java runtime upgrades. And we saw the new full-stack Windows modernization agent.
Which does what exactly?
It automates the migration of .NET apps and their SQL Server databases to Aurora PostgreSQL and containers. They're promising up to a 5x acceleration.
And for legacy systems, mainframe and VMware agents also got big updates. It's often said that half the cost and time in a mainframe migration is just spent on testing.
Right, because the institutional knowledge is gone, the original developer is retired, and nobody knows how the 40-year-old COBOL works. Testing is brutal.
So how do the agents address that?
AWS Transform now has 2 new capabilities. First is application reimagining through data and activity analysis, and second is new testing automation that automatically generates test plans and data collection scripts. The agent is essentially reconstructing that lost institutional memory.
And finally, rounding out autonomy, a huge feature for serverless developers, durable functions in Lambda.
This is a massive architectural simplification for reliable, multi-step applications. Lambda durable functions are now GA.
Okay, so what does that mean in practice?
It means they automatically checkpoint progress, they can suspend execution for up to a year, and they automatically recover from failures. For developers, you no longer have to build custom state machines or use external orchestration services.
The platform just takes on the responsibility for resilience.
Exactly.
It was an extraordinary week. It really shows the cloud is rapidly becoming, well, agent native. We have 3-nanometer silicon designed for AI and autonomous agents handling everything from code modernization to incident response.
The central narrative is that this shift is happening at every layer of the stack. The underlying infrastructure is becoming more elastic, more self-managing, and agents are abstracting away complexity for the developer.
It really feels like the skill barrier is shifting away from managing primitive infrastructure towards defining complex objectives for these intelligent agents.
Well, we've seen platform resilience become a core theme. Think about the connection we discussed. Checkpointless and elastic training in Hyperpod, combined with durable functions in Lambda.
Right.
It tells us the concept of a job failure is being redefined. It's moving from a catastrophic stop that needs manual intervention to an automated transient event handled entirely by the platform.
So the provocative thought for our listeners is,
What other infrastructure constraints are next on the list for AI-driven self-healing abstraction? Maybe global consistency across regions, or even supply chain limits for reserve capacity. Something to think about. We'll see you next time for the next deep dive.